Hello. Good afternoon, everybody. I am from Kirloskar Brothers Limited. We have been known as the manufacturers for the centrifugal pumps. We are here for the last 137 years. We have been working very jointly with BARC, NPCL, DE for development of a lot of nuclear pumps. Besides that, we also worked on many of the pumps going for the thermal application with NTPC. In my presentation, I'll just give you a very brief agenda. In my presentation, I am going to share about the journey into pump manufacturing, our joint ventures, our manufacturing capabilities, and some of our, I would say, the projects that we have done with nuclear. And here I start my presentation. So these are my global presence. Actually, this is my headquarter office in Pune. It is Yamuna. It's a LEED certified green building, platinum rated, inaugurated in 2009. 40% of electricity is through the renewable source, through this office. These are my global presence. We have 6 manufacturing facilities outside India, and we have 7 facilities outside India. We have 6 manufacturing facilities within India. And these are some of the joint ventures and subsidiaries. That is SPP Pumps Limited in UK. It is for the firefighting pumps. Synchroflow USA for the pumps going for the HVAC systems package. Rodelta in Netherlands for the API pumps for the European market. Kirloskar Brothers Thailand, which are packaging pumps for the region of Southeast Asia. We also have Kirloskar Brothers Pump in Netherlands for giving Kirloskar Brothers make pump for the European origin to support the market in Europe. And also Brewer pumps in South Africa. Apart from that, we have a joint venture with Ibarra for Kirloskar Ibarra pumps for API package we make. We have KPML, that is Karar Projects and Motors Limited. Here we make our own electric motors as well for the CAN motor pumps, and we also have the 5-star rating, that is gold standard motors at KPML. And TKSL is a Kolhapur Steel Limited, where we have our own foundry to do our own castings, and this I'll cover in my presentation. Few things on castings, that is our in-house capability, and that is last is KCPL, that is Kirloskar Corobot Private Limited, having a joint venture with Corobot UK for making special coatings going for the pumps in the seawater application and some of the very harsh slurry applications. So this is my journey. We have started in 1901 to 2023. If you see, since my journey from 1903, there are a lot of innovations and the first time new products made by Kirloskar Brothers in India. And we have a long history, in innovating many of the new products. So throughout the journey, if you see, we have made our own centrifugal pumps back in 1926, and then our CAN motor pumps in 1985. If you come to the concrete door pump, 1993, and also if I see the boiler feed pumps, 2016, going for the nuclear application, and also the fish-friendly pumps, boiler feed pumps again, the one for the 700 megawatt, and in 2023 made the cake. We got the order for the main coolant pump for the application of HFRR. And these are our business verticals. Like every business has their own business verticals. So we are working oil and gas, power, water, irrigation, industry, building and construction. These are the products that we manufacture. We have 70 different type of pumps, and also we manufacture hydroturbines as well as valves. We have our own, I would say our own engineering for our own products. So we believe from conceptualizations to manufacturing and implementation. So everything is in-house. So whether it is engineering, making own patents, we do in-house, and also we do the overall R&D. So if you see like CFD studies, seismic analysis, transient analysis, all this analysis also are done in-house. We not only do for our pump business, but our friends in the business also, we cater our engineering services to them as well. So these are all the technical capabilities. I will not go, these are part of analysis, it won't take you much time. And this is the manufacturing capabilities. I'll skip those. Okay. In the foundry, we would say that unlike other foundries, we do have our in-house foundry, but we also have a 3D printer where we do our pattern printing through 3D machine. It's a 4 meter by 2 meter by 1 meter in height. So all the critical castings we do in-house. So we save a lot of time in preparation of the pattern, and also the accuracies are very well matched. So machining is very less required when we have the 3D pattern making through our own capabilities. We have our own quality control, and interesting is that we have our own testing facility to test the pump at a 15,000 meter cube per hour for a 5 megawatt motor, and also this we are further enhancing to the higher capacity going to 70,000, and we can do the testing for the pump required not only for the Indian market for the 50 Hz, also for some going in the 60 Hz market. So both we can do, both the testings we can do here. We have all the required certification that is required to going into the nuclear. In this actually, I'm not highlighting this, we also had the certificate for the nuclear, ASME N and NPT till 2018, but it was too much restricted. We need to go to further certification for the European market, also for the RCCM and others, so that also we're in process to make. And second thing is that we also the leading company in the CII innovation for GreenCo, where 22% of energy utilized in our factory for manufacturing is from renewable source, and by next 2 years 70% of the energy utilized by KBL in manufacturing the pumps will be from renewable source. So this is nothing but to support the not the government of India initiative, but the world initiative to how to go for the net zero. Coming to the KBL offering for the nuclear applications. So we did a lot of developments, like whether it is the pumps going for the fast breeder reactor, whether it's for the pressurized heavy water reactor. So all the critical pumps for the primary side had been made by us. I'll just make it a little quick over here. So we are working with NPCL, and you can see the number of pumps that we have jointly worked with NPCL and developed and supplied. So major all the primary side pumps we have covered here. Also for the Bhavini, the fast breeder reactor, where you see the primary and secondary sodium pump 100% indigenously made with support of the Government of India initiative, and we have successfully supplied this. And also we are working with DAE and DARC for the high pressurized pump, and also for the heavy water board. Here are a few of the examples which I just mentioned to you. Further, the pumps going for the steam cycle for the secondary circuit. We supply all the pumps, that is a cooling water pump, condensate pump, auxiliary cooling water pump. So secondary side is a very common which we do for many years. But for more than last 3 decades, we are also doing for nuclear. For other, we had done more than 50 years. This is very important, the primary coolant pump for the 700 megawatt power plant. This we have indigenously developed, and we have a very dedicated facility for making these pumps, which also I'll cover in my preceding slides. The shutdown cooling pumps that we have manufactured and supplied. Also the pumping solution for nuclear power plant for emergency core cooling system pumps. Pressurized, primary pressurizing pumps. Containment spray system pumps. And also the can motor pumps. More than 1,000 can motor pumps we have successfully manufactured and supplied. We also make our own electric rotor for all these can motor pumps at our KPML factory. We have also successfully manufactured the boiler feed pumps going for the 700 megawatt unit, the pressurized heavy water reactor. This is also manufactured and supplied successfully by us. And here are the few photographs for the fast breeder reactor for the sodium pump. This is the secondary. And also the pumps, that is condensation action pumps, concrete volute pumps. These are the first type of its kind of a concrete volute pumps handling the seawater application, supplied for Tarun power station. And also we have supplied this concrete volute pumps for the fast breeder reactor at Bhavini. It is a very unique design, actually. Complete I would say the CFD study, model study. After that, we completely help in designing. If you see over here, that is the this is the seashore. Directly there is an intake channel, and in a very small 4-bay we have to make the pump house. And here there is no standby, so the reliability is also very high. So this is a very good option for having the pumps made in concrete volute for seawater application. Also, we have supplied pumps, few of the pumps for the ITER France, the cooling for the cooling loop application. And this last I want to just share you about our Advanced Technology Productive Division, ATPD. It's a 6,000 square meter area, plant only dedicated to manufacture and supply the pumps going in primary circuits for nuclear. So there's a machine shop wing. This is the assembly shop. And the pump testing by, that's a very, very critical loop that we have already manufactured, and we have tested the pumps here and supplied. And also the dust-free welding room. So with this, actually, you know, in my very short presentation, I gave you a brief about our own capability, our presence, what we can do. What we have to share here is that, see, we all are moving in a direction to go for like SMR, BSR is there. So we need to be industry ready for the upcoming requirement. I think Government of India, NPCI, BRC is working in directions. There are a lot of things to be, you know, connected through policy makers and other things. But I think industry need to be ready there, and I think like we are ready for the pumps. Of course, I feel that around the globe, other pump companies or the equipment manufacturers, we are there. Today at this platform, when we are presenting to INIP, I think this is my second time. And I'm glad to see that post to our past presentation and presence here, and the other OEMs who have come or other technology suppliers who are there. They're very interacting. How do we exchange things, you know? But at the same time, we want to see that there's a good synergy between I would say the policymaker, the OEMs, also of course the Government of India on the plan. We have been having engaging discussion with NPCL and BSC. My only request is that, you know, we already put some timelines to the things that we are planning. But if we have, you know, some more visibility to the roadmap, it will help us to more invest and, you know, more align ourselves to be together. And I would say, like all the OEMs, we need to have more cooperation rather than competition to see that how we can deliver the things better. That's all. That is my message to all. Thank you.
Thank you very much.
Thanks.
Any questions? Thank you very much.
Thank you. We have a stall here, so please, if anyone have a question, you can please reach us. Thank you.
Of course.
It's a pleasure. It's a pleasure to be on stage here and talking about Arabelle Solutions. It's a new formed baby as an organization with a very old legacy, almost around 60-70 years of presence in the nuclear industry. We are a business which has recently been acquired by EDF, and so we are an independent company within EDF operating with a multi-reactor approach. So I'm here to introduce Arabelle Solutions as a company, its business activities, and our long presence in India as a country. So my presentation, I would cover with the introduction of the company and about steam turbines and India presence. So in just numbers, if we have to talk, we are a company with around 1/3 of the installed base around the world for the TGs. So the turbine generators, the installed base of around 150 gigawatt it comes from Arabelle Technologies solutions, technology and supplies. And the turbine output range is from 50 to 1900 megawatt output size. We, on an average, we service 100 nuclear plants annually. And the largest last stage blade that has been manufactured in the world is around 75 inches, which gives you one of the highest performing turbines in the world. And this is for a project in Hinkley Point C in UK, which is under construction. And so that's that's a broad introduction. Basically, we are all about turbine islands. So we've built our legacy of 60 years to offer technology and solutions for turbine islands for all reactor types. Whether any type of nuclear reactor in the world from any company, any technology, our turbine islands with whether be the complete island or individual components like turbines, generators, moisture separator, heat exchangers or pumps, they are more or less adaptable and available to align with all reactor types. So whether VVR, AP1000 and EPR or the Kundan reactor or the NPCI alone indigenous reactor. So we are there and offering solutions for all of them. So in terms of the offerings, we start right from engineering studies for complex new machines or new projects to equipment supply on a partial EPC or complete EPC for turbine island scope, and going up to, of course, giving doing commissioning support and after service for major part repairs, emergency repairs, or also doing upgrades and retrofits, life extensions. Again, applies to all reactor technologies. We have a strong international footprint, being present in around 16 countries with 3,300 employees in this business, and with around 5 factories, with 3 in France, 1 in Rugby in UK, and 1 in India in Szenes, Gujarat. And we have in India we have an office in Noida also, where we have an engineering presence. So we have around a network of 1,300 suppliers helping us cope up with this international requirements. On the turbine island equipment side, of course, we have steam turbines. Could be divided into largely two segments. One is the Arabelle steam turbine, our flagship turbine, which is in the output range from 1,000 to 1,900 megawatts, and the STF series for lower size reactors. Then generators, heat exchangers, pumps of all categories, nuclear controls, and we also then are in the business of buying mechanical equipments to integrate for the turbine island for the equipments that we don't manufacture in-house. So I think the next slide will give you a better view of our in-house equipments designed by us, manufactured by us, some in-house, some outsourced. So the leftmost item is the steam turbine, which you can clearly see in 2 categories, the Arabelle and the STFN series. Generators, so steam turbines and generators are in-house manufactured items, whereas for heat exchangers and pumps, we design them and we outsource them depending on project locations. We have a supply chain and we get them manufactured. Nuclear controls are in-house, and of course digital is in-house. I think now we move to the topic which is more relevant for our presence in India with respect to the steam turbines. Steam turbines largely, as you can see, that the range is from 50 to 1900, which I mentioned. We have fully adaptable steam path, deployable in any location and all cold conditions. And we have both reaction and impulse blading. And we can proudly say that our turbines are one of the most efficient on the market. And wherever applicable, we also have features like single bearing between 2 turbine modules and the generator, and welded rotor, which is a niche technology by us. And then coming to SMRs, we have a turbine output range from 50 to 600 megawatt. This again is suitable to all SMR applications worldwide for all projects that are going on. We heard some speakers in the morning talking about 80 types of SMRs worldwide. Among those 80, we have selected few which we feel are most viable ones, and we have our turbine supporting them in our proposals. And we are proud to say that, in fact, we have almost finalized the first SMR turbine for GE Hitachi's project in Darlington in Canada. And we have plans to manufacture this turbine in our Szenes factory in Gujarat. So we will start, I think we would be having this pride in saying that we've been talking a lot about SMR in the country for the last 2 years. I've been attending so many conferences and seminars, Niti Aayog, G20 and NPCI. But it gives me immense pride to say that as one company in India, we will start manufacturing a turbine which will get delivered for an SMR project going forward. So that's indeed a success moment to us. Something on the range and the output categories of our turbines. We would classify Arabelle turbines into two output ranges, 700 to 1300 and 1200 to 1900, and then STFN series for the smaller reactors. So we have modules, we pick up modules from this family of turbines, and depending on the reactor parameters that come to the turbine, we build up a turbine for a particular application. So being an original designer, we can configure a turbine for any application, for any output size. It's this family from which we select the turbines. So the Arabelle steam turbine around the world, this is a very interesting slide. It talks about the machines which are 1000 megawatt and above. So we have around 44 machines of this size, and you can see the two color coding in the slide. The dark blue is the machines which are operational, and the light blue are machines which are under execution, including flammable, which you see there. And the reliability of these machines are par excellent. I mean, we talk about 99.96% reliability, which has been adjudged over 10 years of operation of 4 machines in EDF's own plants over a 10-year period with forced outage of 0.04%. So gives extremely high reliability, 99.96. And this Arabelle is a special turbine technology with a configuration which compared to the normal classic configuration with single _HP machine, we are able to generate 2% more output, and so it's a unique feature of the Arabelle technology. This technology is being offered in India through Jaitapur project with NPCIL, where our scope is for 1740 megawatt single turbine, 6 units. And now the most interesting part, our India presence. So we're proud to say that our presence in India is from the first nuclear power plant set up in the country. The Tarapur plant, the 160 megawatt turbine, is from our portfolio. Till the last turbine order that has been ordered by NPCIL just 2 years back, the Gorakhpur 𝐓𝐈𝐌𝐄𝐒 machines. So many firsts, from 160 to 100, the first 100 and the 200 megawatt machines of NPCIL for Rawatbata, the first 220 megawatt machine for MAPS, followed by 12 more units of the 220 megawatt, which were manufactured and supplied by BHEL under our technology license. And then the graduation to the 700 megawatt. So the first 700 megawatt machines for Kakrapar and Rawatbata again were jointly done by BHEL and us. And we have seen it tested and performing. It gives us pleasure that the 700 megawatt is also operating quite well. And then we moved on to the Make in India Atmanirbhar Bharat focus of the current Prime Minister, and we joined hands with BHEL to do a technology transfer and a business cooperation agreement in 2018 for the next stage of NPCIL 700 megawatt program, and it resulted in the next bulk order, where the Gorakhpur and the 𝐓𝐈𝐌𝐄𝐒 machines will be manufactured in our factory in Sanand. So as we talk, it's an order under execution in Sanand, and 3 machines are being manufactured by BHEL. So if you talk about our presence in NPCIL, almost all NPCIL plants in the country have our turbine supply or technology, barring one, which is an imported machine, the Pudankalam. So that's where we are not there. Otherwise, all NPCIL plants have our technology, and covers the entire range from 100 megawatt to 60, 220, 700. And of course, now we are gunning for the 1740 megawatt, the Jaitapur, which is going through interesting times. And about our factory. So we have a manufacturing factory facility in Sanand, Gujarat, which is set up on 46 acres with an investment of $200 million. The groundbreaking was done in 2013. And we started manufacturing in 2018. 15 we started the manufacturing, and by 18 we had started rolling out turbine generators for 660 and 800 megawatts for the coal plants, for NTPC and other projects. We have delivered more than 20 turbine generators of 660, 800 megawatt for the thermal applications from this factory. And this factory has delivered in all around 31 gigawatt of machines and for new build and services. Currently focused as a factory for nuclear. We are getting geared up to manufacture turbines from 25 megawatt to 1200 megawatt. So within our company, this factory is earmarked as the factory to manufacture steam turbines for the SMR requirements worldwide. So as I mentioned, we'll start soon with the first turbine, but we are going to supply steam turbines from this factory for the globe for all SMR requirements going forward. So this factory is getting clearly focused on the nuclear side, and in fact, as a company strategy, many components of our large machines for projects internationally have started being manufactured here. So for 𝐓𝐈𝐌𝐄𝐒 and 𝐓𝐈𝐌𝐿𝐿 projects in Turkey and Egypt, their bearing pedestals and LP casing, we started manufacturing here. So this factory is now getting positioned so that we hear about our industry folks in India in all conferences, including today, that we need a sustained load as an industry to run our factories and have competence kicking when your projects come here. So we are fortunate having access to the world market, and so in lean phases we are there to get load and service our global projects from here. So that's a conscious effort that the organization has taken, and so we get geared up to be ready to deliver global and Indian projects from here. We are qualified for ISO 19443. That's given for a nuclear business. And then we move to our engineering presence in India. So we have around 100 engineers working on nuclear projects in our centers in Noida, Bangalore and Sanand. So that's a big size of engineering strength for any manufacturing entity to be based out of India and having this much of engineering presence. So our engineers work from conceptual design to detailed design, on product design, and also on plant integration. So they've been working on, there's a high involvement of this engineering strength to support our global projects of Darlington, 𝐓𝐈𝐌𝐄𝐒, 𝐓𝐿𝐷ABA, EPR, Zudupu, and also the Indian projects of Gorakhpur. So in a nutshell, we are completely present on the entire value chain of an organization, from an installed base in the country to a manufacturing facility and an engineering organization. And as an organization, we tend to grow the India presence to support the Indian market as well as the global market. That's the strategy of the new owner, EDF, a clear direction in which the organization is working. And with this, I close my presentation.
So this is the last session before you get a break, and I must say it's been a very, very interesting day's worth of conversation and discussion we've had today. I'd like to thank our business partners for the fantastic job they've done, as they do every year, not just here but around the world as with other conferences. So thank you very much. So those of you who don't know me, I'm Jasbir Sidhu. I'm the immediate past president of the Nuclear Institute in the UK. I'm based in London. So my background is I'm a nuclear engineer, and Chernobyl's been mentioned a few times. So back in 1986, when Chernobyl sadly blew its lid off, that inspired me as a youngster to study nuclear engineering. Went off to university, got a degree in nuclear engineering, did an MBA, and then set up a consultancy organization, Corporate Risk Associates. Developed and operated that in the thought leadership space for safety and risk, and sold it to Assystem, another French company, working closely with EDF, who you would have just heard of. And having done that and developed thought leadership and professionalism in the industry, today now I'm championing the cause of nuclear via nuclear insurance, reinsurance through the Lloyd's market, and also developing a fund to invest in nuclear assets around the world. So before I invite my panelists to come and open up this topic, I'll just share with you some thoughts. First of all, a few weeks ago I chaired a session in London at the City and Financial conference. Now this was quite different, this conference, because it's one of the first conferences where you had renewable people sitting in the same room as nuclear people. Now this for me was a bit of a novelty, because usually you just have a nuclear conference, like we are having here now, and a separate renewables conference. And they talk more or less the same things, but switch the words nuclear for renewables, renewables for nuclear. So for these organisers it became abundantly clear that we do need to start talking to each other. And the reason for that is, if you look at what's happening back in the UK, which is not that dissimilar to here, when it comes to our energy mix, we are, believe it or not, burning a lot of gas today. We no longer burn coal. We've finished burning coal at the end of September this year. But for now, we're probably burning about 60% of our energy needs are coming from gas, about 15% from nuclear. So in the UK, we're on a trajectory to achieve net zero by 2050. Over here in India, it's 2070. But there's a much bigger job to be done here than in the UK. So back to the scene setting. What's interesting is quite a lot of the topics have already been covered. So there's the increase of demand in the world, trebling of power around the world, 22 nations, COP28, COP29, another 31. Everyone wants nuclear. Why is that? Because there's a great big desire for energy security and independence, but very good reliability is needed and availability. And seeing turbines with the efficiency and reliability that's just been put up by Arabelle is very impressive. The big thing is that brings nuclear to the forefront. One of the things that we haven't touched upon today is how we generate and use data, and where is data stored. So the first point is data is stored in data centers, as you know, but there is a big push and drive to develop more data centers. So the recent studies suggest that by June 2024, Microsoft will have around 300 data centers, AWS 215, Google around 25, Meta 24, and Apple 10. Now that needs to treble to keep in touch with the demand of AI that we are using and what we're doing with the information we're storing. So that leads to, you would have all heard this in the press, owners of data centers, your Microsofts, AWS and Googles, taking up power purchase agreements and investing in nuclear. So Microsoft Constellation Energy, they have a 20-year power purchase agreement from 3 Mile Island Unit 1. Unit 2 is closed for 1976 accident. AWS is investing directly in SMRs, and so is Google. But the studies have shown that by 2027, which is not very far away, the total consumption, the electricity consumption of data centers alone is going to be equivalent to the amount of energy that the nation of Spain uses in a year. So you're talking about 125 gigawatts of power. Now, that has to come from somewhere. It can't just be dependent on grid, can't be dependent on intermittent supply of wind and solar. So that's where nuclear, providing a good base load, or direct wire, direct feed, becomes very, very interesting. And as you all know, there are 60-odd reactors under construction in 16 countries, quite a few of them are here. We in the West are a bit slow with our construction. You would have heard how long it takes for us to come through planning, some of the issues we've heard here today. So in summary, based on the discussion we've heard so far, what are the issues that are going on so far when it comes to India here? So obviously the civil's liability for nuclear damage is perceived to be a great blocker for private inward investment. Will that happen? Land purchase agreements, state-owned, is an issue. If brownfield sites are going to be developed, which there's a desire to put captive, smaller captive plants to provide generation, then having exclusion zone of 1.6 kilometers, natural growth zones of 5 kilometers, EPZs of 16 kilometers, and radiation surveillance zones of 30 kilometers just isn't going to work. So I think the penny has dropped, not just here in India, but in other jurisdictions as well. Regulation needs to change. But what can we do in the meantime? Now, when it comes to fuel, fuel needs to be provided, it needs to be managed. Once the fuel is used, it needs to be stored. So that fuel will have to be stored on sites. Some studies I've seen are indicating that if you're looking at 40 to 50 SMRs, BSRs operating, you're looking at 1,800 tons of spent fuel after a 60-year program. So what that means is that we need reprocessing facilities to be built. You need a decommissioning perhaps board to be set up, and probably a nuclear waste repository as well somewhere. Now that will require strong social license, and that discussion needs to start now, because it's not just about the technology. I firmly believe there's nothing wrong with the technology. It works, it's safe. The other thing I should mention is 2 weeks ago, when I was at this conference, being a nuclear safety engineer with a bunch of renewables people there, we never mentioned the word safety once in that whole day's conversation. Because in renewables and in other industries, safety is just taken as read. You don't have to carry on talking about safety. We have a bit of a bad habit in the nuclear industry of just banging on about safety. I think we should do less of that personally, even though I'm a safety engineer. So all of that means that we need to press on now in the Indian nuclear program with deregulation and trying to think of clever ways of decentralization and looking at new business models for broader participation of private developers. And that's what we are here to talk about today. So I think that's enough for me for now. I would like to invite along our panelists. First of all, I'd like to invite Mr. Kundan Kumar, who's the Deputy General Manager NTPC. Please come on. I'd also like to invite along Mr. Gabor to come along, take his seat. And then also Mr. Satish Joshi, who's the Assistant VP of Godrej and Boyce. And I forgot to say, Mr. Szenes is from Arabelle Solutions. Thank you very much for our panelists to gather together. I think we'll start by asking each panelist to introduce themselves and start to share their thoughts on how we can approach this subject of decentralization and trying to speed up projects, or speed up the way we can get governments to take their hands off, or less tighten their hands around the nuclear operating that we need. Would you like to start, Satish?
I'm Satish Joshi. I'm working for Godrej and Boyce. We are based in Bombay. I'm coming from their nuclear division, so my expertise and experience is in design and more of a manufacturing of PHWRs. Then there is PFBR, and also we are working on LWRs. So most of the assemblies we have done in Godrej successfully. Many people have said since morning, yes, Indian industry can do. We have sufficient talent and capability to do these reactor components. All critical components we have done. Today we are talking about decentralization of nuclear power. The idea of decentralization is very profound, very solid in the sense if we go on having a very ambitious power generation plan, electricity generation plan, I think we are going to need at least 10 reactors every year in next 20 years. So with that type of reactor manufacturing, that's the only way India will fill the gap. Now if we do it in a conventional way, I'm sure the grid is going to get heavy load. So there is simply no point in generating electricity somewhere and using it somewhere else, just transporting to the grid. Grid overload is actually seen in Europe and America because of heavy grid utilization. So this decentralization is a correct idea to use the location of usage and location of electricity generation is same. So it becomes independent of grid. Now question is, what are the bottlenecks in the process? First thing is, many people have said, safety remains the foremost concern. Spent fuel, as he suggested, is also a concern. But to me, the major thing is, if we are intending to have private participation, then the private industry should be attracted to this proposal because they are going to do major investments. And what they are actually looking for is a sustainability and viability both. So unless the economics is worked out and there is a surety of the application, so surety of the power requirement over the years, then they will interested. Certainly industries will be interested in, and then they will go for this particular approach. So that is one thing I would add.
Good evening. Myself Kundan Kumar. I have more than 20-year experience of NTPC in different area like O&M and project execution and project management. Although NTPC is very new in this field, we have just launched our new joint venture with NPCL, that is called Ashwini Anusakti Vidyut Nigam Limited. Parallelly, NTPC is also opening a new forum, that is NTPC subsidiary company for nuclear business. That is also going to start. As far as the today's topic is concerned, this decentralization. Decentralization is not new concept, but for nuclear it is a new concept. Why this decentralization concept has come into the picture? When we have started this modularization concept, SMR and MMR concept, then we started thinking about the decentralization. Because a large reactor, you cannot decentralize all those things. So now some of the design of SMR has matured enough, so we are thinking in this for decentralization. Some of our India is surrounded by many islands, so we can think of putting this SMR, MMR in the islands where the transmission and distribution is very difficult. So that's why the today's topic, this decentralization, has come into the picture. And the second part of this topic is the business model for private sector participation. Now, if we are going in the decentralization mode, so it is not possible for a single government utility to do all those things. So definitely private sector participation is must. So the today topic of business model for private sector participation is also very relevant for them. Thank you.
So hello, my name is Gabor. I am for 20 years in the nuclear for steam turbine business and sales. Spent some significant time in India as well. So about the topic which we're discussing and how to attract the interest of private investors, I thought to share how is it currently in the international market, what we see, because international market private investors are in many countries present in the operation of nuclear power plants. Of course, the countries which are successful in this are either semi-regulated or non-regulated countries, because I think, as was mentioned today already, the private investor is looking for a return of investment and, of course, looking for a stable legislative framework for investment, even if the private investor is very cautious about the long-term return on the nuclear. So if we look at this angle, and of course we cannot really today discuss about SMRs, because the SMRs are not broadly, let's say, operated except China and Russia. But on the large units, there are mainly two schemes which we see. One scheme is more on the semi-regulated market. It's a PPA, so the grid operator or the main, let's say, utility is proposing a PPA which is attractive enough and securing sufficient time of return for the private investor. The other one, which is a bit more tricky, is when the nuclear power plant is used as a non-profit organization. And as a non-profit organization, the shareholders of this utility receiving the generated power as a dividend and selling it on the market or using it themselves in case they have own captive industry where they can use. In this way, you can attract the private investor where they signing a contract with an operator, which having a license from the local regulator for the keeping, let's say, the nuclear power plant in operation, plus a contract for supplier fuel, and 3, 4, 5 companies, traders, or again, could be private investors, simply as a shareholders receiving the generated power are proportional to the shares in the company. This is, for example, where I'm living in Switzerland. This is a standard way. The 3 or 4, let's say, larger utilities are owners of the nuclear power plant in Switzerland. But also a good example, if some of you heard, in Nordic is a quite not decentralized power market. And in Finland, they're using a scheme of Mankala, where we were working with a utility. There were 35 small enterprises who are joined as a shareholder of the utility in order to operate a nuclear power plant, and simply these joint small enterprises generated sufficient assets in order to get banking financing for a large project like a nuclear power plant. And the return was based on the hourly, let's say, power generated by this power plant, which they could sell on the Nordic energy market. And this working, it exists. So of course in India, in every country it needs to be adopted, but there is very good examples how the private investor can find an attractive scheme to invest in so a large infrastructure project like a nuclear power plant.
Thank you very much for that. Thank you for the introductions and your early thoughts. So if I may start with Mr. Kumar, it's fantastic to see that, let's be positive today, that the 𝐓𝐈𝐌𝐄𝐒 project venture is going ahead. My understanding is the shareholding will be 51% NPCI, 49% NTPC. So there's still control, but it's beginning to loosen perhaps that control. Can you elaborate a bit more on how mechanistically that will go forward, that whole venture, such that it then starts to tries to convince private investors that investing in the Indian nuclear market is a good bet? And just as an outline. In recent times, those who've been following the New York Stock Exchange, there's been a big spike in the stocks of mining, uranium mining and nuclear companies, especially after the announcement by data center clients that it's a good bet. So the point is there's a lot of private capital there that could be brought to help develop projects and other investors get involved. Can you share your thoughts there, please? Thank you.
Yeah, well, I do have to say, NTPC is hello. Yeah, as you have told, I have earlier told, NTPC is entering into 3 options. First is, through NPCL, we are making joint venture for this 𝐓𝐈𝐌𝐄𝐒 projects, the Indian technology projects. Now, the NTPC is also making a subsidiary company. So that subsidiary company will solely look for SMR and foreign technology reactors. Now, the question is how we will encourage the private participation. So really the nuclear project is very capital intensive project. So for any company it would be better to collaborate with private players. So there are many business models available in worldwide, like Europe, as Mr. Toli telling. So Mancala model, 𝐓𝐈𝐌𝐄𝐒 model, and RAB model. Like that, many models are there in the foreign countries. So in the same model, we are also thinking that once the nuclear subsidiary company of NTPC, so we are planning in that way that, but the government should allow that thing, that 51% administrative control should be in the hand of the government. So majority partner will be the government company and 49% partner may be the private player. And private player can join hands during construction period. They can, after construction, it is up to them. They can dilute their share, and it is up to them. If they want to continue with that stream, they can continue, or they can withdraw all the share. And so this is a type of SPV model. So that type of SPV model we can think of, but all things depends on the Government Atomic Energy Act regulation. So first of all, the Government Atomic Energy Act has to be revised so that private players can participate. Yes, the administrative control should be in the hand of government, government-controlled company like NPCL, NTPC, whatever be. So in that model, we can participate private players in this business. Now the second question is the fuel security. For fuel security also, NTPC is exploring the options of joint venture with UCIL and NPCL, so that we can have our own Indian capacity, but we can explore the mining, overseas mines also, acquiring overseas mines and import the fuel from that mines and do fabrication. Already we have the capacity of NFC and NPCL. So with that way we can ensure the fuel security also. So these are the planning, but the whole plan depends on the Government Atomic Energy Act provisions, which needs to be revised.
He has already told exactly how the good roadmap is. Only one or two points I will add is we need a very good design, proven and standardized. Once that is done, then the many players will go with the same design and then invest. And another point was about spent fuel storage and decommissioning. So government has to do something for that area so that the private players will be comfortable in, they feel that the viability of the project is good, and once they think like that, then the investment is possible.
So Mr. Szenes, would you like to add anything to that? So it's the idea here is that there is a movement now through this JV where nuclear seems to be opening up in the Indian market, but how can it be accelerated Otherwise, we'll always just come back and say, until the law is changed or developed, then there's not a lot of hope. But there must be something we can do in the meantime. Because if there isn't, then we might as well go home now and finish this conversation here.
I mean, acceleration just means that you need to understand what drives the interest of parties you want to involve. So if we talk about, like in India, iron and steel, alumina, who are suffering from, let's say, shortcuts on the electricity, and they want a stable, sustainable source of power, and they cannot use any more fossil, then of course you need to understand what they want. In my view, the private investors, so let's say, the capital is available, the funds are all available. You need to design the structure that these investors will see on the return, whether it will be in kilowatt hours or it will be in rupees when they can sell on the market. And it's not anymore, so it's not an issue in the world, the safe operation, which you were saying. India follows the logic as per the Atomic Nuclear Act that the owner and operator should be a state-owned company, which is fine. It does not exclude the fact that you can have private investors who can, I guess, as we said, getting payment for the investment.
Thank you very much for that. So if we talk about a timeline, Mr. Kumar, based on the discussion you've given, what timeline would you put down for that journey for deregulation, which would include the changing of the law to make the market a bit more attractive to investors, as Mr. Szenes has said?
Yeah, actually, when we talk about the implementation phase of this private participation, we can divide this into 3 phases. First, the 1 to 3 year phases, where the government should immediately revise their Atomic Energy Act and start with a pilot project, so that in that pilot project the private player will be participated and get acquainted with the Indian Atomic Energy Act and the Indian systems. Then next 3 to 7 years, that 3 to 7 year period, a large scale project will be started through this private player involvement. And after 7 years, means 7 to 15 years, we can get full maturity of that technology with the private player, and India can become a nuclear hub. We can start exporting the nuclear components or equipments and even technology also. So this is a horizon of 1 to 15 years. We can divide it into 3 phases. So 3 years, then 7 years, then 15 years. So with that timeline we can think of, but all that depends on that revision in Atomic Energy Act and regulation.
No, thank you very much for that. That's very clear, and I like the way you've split it into 3 phases with your 3, 7 and 15, which is very clear for all of us. So if we now take that further, so within a 15-year model, if we look at the United States has a deregulated marketplace. I believe they have 30 nuclear operators operating around 30 states. In the US, that's about 98 reactors. They have 3,500 licensed nuclear operators. But the point is there's 30 licensed nuclear operators. Do you think India will head to that sort of model by beyond 15 years to meet the 2070 net zero objectives? Because I feel perhaps more needs to be done. And India is not unique in this, because that sort of model probably needs to be emulated around other jurisdictions around the world. Shall I give this one to Satish?
You asking me whether India will move towards the scheme of the US market? I guess no. What you need to take into account that the fact how strict the regulator itself and how they are, let's say, safeguarding the operation of the units, of course defines how the utility will operate at the same time. So you don't need to be afraid that the non-government utility will cause damages to the society, because these companies, as example of the US shows, they are obviously responsible for the shareholders. Most of these companies are listed companies, so their direct interest is to generate profit and not, let's say, causing unreliability in the net or shutting down at the wrong time the units and so on. So there are different schemes, but that's why I said before, it's not, in case India will choose or will keep the requirement to have a state-owned operator, it still have different scheme of partnership, lease, which will allow the private investors to come in and, let's say, grow the nuclear fleet in India.
Thank you very much for that. So I suppose the question I have for Mr. Joshi is, based on the discussion we've had, we've got a timeline of 15 years. We also heard in the morning discussion that India's GDP needs to grow between 7 and 8% between now and 2070 to meet net zero obligations. The model which we've just discussed and the timeline that we've just heard, between 3, 7 and 15 years, would that be sufficient to meet the nuclear requirements and helping the nation achieve its GDP growth objectives of 7 to 8%? What are your thoughts on that?
A little maths if you do, then I think our target is around 50 gigawatt by 2050. And then we expedite it further in the next 20 years. 50 gigawatt by 2050 needs 20 gigawatt to be added in 20 years. So that is the speed at which we have to do the reactors. I think we are late. Frankly speaking, we are late. In the sense, SMR and BSR, there are two options. BSR is ready and maybe it will still take a couple of protos, like he said, to productionize. But SMR is way behind. Unless we do the protos fast and we start productionizing by 2030, I feel it's late.
Hello. Just I want to correct you, correct in this part. Whatever the timeline I have spoken, that is for the involvement of private player, complete involvement of private player from R&D phase to operation phase. So I have given this three timeline. One for involvement of private player during the R&D phase for pilot project, then middle portion is for construction and operation, and then final portion is for, so that is the complete involvement. But we can start thinking from today itself, if we are going to implement this SMR and MMR and all those things, then different models are there. Through that, private players can start participating in. And obviously that is doing also. If you see that EPC mode, all private players are there in EPC mode. Only thing that operation part is there, that operation part is taken care by the government authority, then like NPCI or whatever the new Ashwini and Bhavani will come in the next future. So that will be taken care of.
Thank you very much. So should we come on to how can we achieve that deregulation? So one of the barriers is public opinion, and politicians are very sensitive to public opinion because they need to win votes. There's been an election in Maharashtra state. So the question is, how as an industry can we help the government achieve its objective of educating the people that nuclear is needed, such that it then helps with the deregulation story and then everything else falls in line according to the timeline that you've given. So for example, for me, when I talk to anti-nuclear people, the message I tend to give is, well, we live in a different world now. So if you are used to taking pictures and videos of your loved ones and everything else you do at work is sitting in a data center somewhere in the cloud that's powered by something, and that power is soon going to be nuclear. You can't accept nuclear, because if you do, then you're going to have to start removing all the information you have out of the cloud and probably live off the grid. So how can we get some messaging out to help accelerate the changing of the law across the nation and beyond? Would you like to take that one first, Mr. Szenes?
Thank you. You have very complicated questions. I mean, I understand the topic is complicated, of course. So if we just take the India, then based on the current kilowatt-hour price in India, the private investor will not be satisfied. So we need to look for other benefits the private investor will have. The private investor and the, let's say, usual return of investment in the power is like 20 years, max 25 years. Nuclear is extremely huge capital investment, so difficult to make sure that you will have a rate which will fully return in 20 years. So what I see currently, what we are looking at, these industrial big companies in India, they see a benefit of having the green energy used for generation of iron steel, which increasing the export market, which provides them a markup, which is a benefit going above the kilowatt-hour price. So this looks like something for Indian market is a viable solution. Again, going in the current regulated market with a private investor, even if it's a public-private partnership, in my view, it's a very difficult financial scheme and not sure that it can work.
Thank you for that. Would you like to take the question, Mr. Satish? Public opinion, any thoughts? No, okay. So let's talk about alternative uses of energy, and then we'll ask some questions from the audience. So touched upon alternative uses of nuclear, which are good in terms of providing captive for heavy industry users. Is there a program in India that is developing to start to think about heavy uses of energy, maybe hydrogen generation, desalination, fertilizer production, etc., that's ongoing, that helps with a case to put to the public that it's a good thing to invest in nuclear?
Yeah, this SMR, the feasibility of SMR, which we are talking about. So we are talking, one part is electricity generation, the second major part is that which you are talking about, the desalination, industrial heating, air conditioning. All in this part we can use this SMR part, and we can utilize this such type of industry for this nuclear plant. Because electricity generation, yeah, everywhere it is going on, and it will go as its pace. But we have to explore this area also for this utilization of nuclear plants.
One addition, we have a green hydrogen mission, and lot of application can simply use the power to create hydrogen. So some of the SMR should be planned for green hydrogen. That's where companies can actually invest faster and come to the...
That is pink hydrogen, yes.
Yeah. Okay.
That's very good. So that concludes this panel and concludes the event. I'd like to give a big round of applause to our three panelists. And thank you very much for putting up a good discussion on a very challenging topic, but it does need to be discussed so that we can accelerate our nuclear programs. Thank you.